Did you know that Microsoft has a full offer to secure your IoT and OT solutions end to end? We have Philippe Noret with us today, who's an expert in security and also leading the teams developing these tools for you. It's today on the IoT Show. Hi everyone, thanks for watching the IoT Show. I'm Olivier, your host, and as you can see here, we're going to talk about security on IoT end-to-end solutions in the world of IoT and OT. And for that, I have Phil Noret with me. Phil, how are you? Comment ça va?
Ça va bien, Olivier. I'm fine, thank you.
So Phil, for people who don't know you, who are you? You've been at Microsoft for like since August, right? It's pretty recent.
Yes.
Give us a little background about yourself.
So thank you, Olivier. I joined Microsoft as a result of the acquisition of Cyberattacks, a company that specializes in IoT and OT security. And I'm the director of Azure, IoT, and industrial cybersecurity at Microsoft.
Is it fair to say that with your experience and you know the different jobs you had in the past, you worked for Symantec and other companies like that, you kind of know what security is like in real life?
I've been around security for a while. It's really a topic that I love deeply, and it's great to be at Microsoft that has such a great portfolio of security products.
Nice. So here our audience is, you know, IoT developers, implementers, architects, or just like people interested about what's going on in the Internet of Things space. And so what we'd like to do today is for you to walk us through, you know, a high level of what is OT security or security for OT in our realm, and then eventually walk us through some scenarios, like real life scenarios, not as I was mentioning and joking about, you know, not the fish tank in a casino that's been hacked, but something that actually is, you know, the various details of actual cyber attacks that happened and the impact that they had. So let's jump into that with that first question. What is the definition of security for OT, for the operational world?
Sure. So, you know, IoT is a very broad topic, but when we talk about OT security, it's a term that Gartner defined to differentiate from IT security. So whereas IT security is primarily concerned with protecting digital assets like containers and databases, OT security is about physical assets and physical processes like turbines and mixing tanks and HVAC systems in buildings. And so the implications are different. Instead of trying to steal sensitive data, the adversary is trying to shut down your factory or is trying to blow up your factory, or maybe trying to steal the intellectual property of your formulas for the pharmaceuticals you're producing in the plant. Or they might be trying to you know, cause a safety incident because it's a nation state. So there's different implications when you're talking about OT security versus IT security. And as a result, it's become a board level issue.
I see that what you mentioned is actually a bit more scary than just, once again, the fish tank that's been hacked and some money has been stolen. Actually, there's actual risks. How about you walk us through a real life scenario, something that really happened, you know, and how the hackers, you know, went through different walls and managed to hack a full end-to-end OT system?
Sure. So we're going to talk about an attack called the Triton cyber attack. This was an attack on safety controllers in a petrochemical facility. And safety controllers are specifically designed to shut down the plant when unsafe conditions are reached, such as the temperature or the pressure in a tank going above a certain threshold. And so what we're going to see is how the adversary got into the facility and installed their malware on these safety controllers. Now, you're going to recognize this is a kill chain, so it's not that much different than kill chains you've seen before for IT attacks, but there are going to be some differences as well. So if you can just start the click, Olivier. The first way they got in was through a phishing attack. No surprise, we've seen that many times before. And the purpose of the phishing attack was to steal credentials, enabling the adversary to have remote access into the OT network. So if you click again, you'll see they got access to the OT network, and everything to the left of that blue line is IT, everything to the right is OT. They installed their malware on this engineering workstation. This is a standard system that control engineers use to reprogram the controllers in the plant. So they actually wrote their malware in Python, compiled it into a Windows executable, installed it on that system. And what was different about this attack, we've only seen a few times in the past, was they purpose-built their malware to communicate directly with that safety controller using its native industrial protocol called the Tri-Station protocol. So here we're starting to see some of the differences between IT and OT security. You have to use specialized protocols to communicate with these devices in the environment. And then their plan was to disable that second PLC, that safety PLC, with the malware. And they had a whole protocol that they wrote so they could communicate with their backdoor, and then launch a second cyber attack that would cause damage to the facility and potentially loss of human life. Now, unlike IT environments, OT environments in most cases don't have any monitoring or telemetry in place to be able to detect this kind of attack. So if you click it again, you can see, had there been any monitoring in place, they would have detected this attack in the early stages. Just click it for a second. And they would have seen, for example, the adversary scanning the environment, looking to see what devices were installed there so they could write their malware to fit into, actually they fitted into the firmware memory region of this device. They loaded it into the user memory first, and then from there they put it into the firmware so that it would be persistent. So this is a perfect example of, had there been monitoring in place in these environments, they would have detected it. Now, for years, most industrial organizations didn't worry too much about security because they assumed their OT network was air-gapped or completely disconnected. That's changed dramatically in the last few years. First, connecting it to the IT network so you can get real-time intelligence, connect it to your SAP system. But with industrial IoT, it's even more bigger attack surface and gives attackers even more ways to get into the OT network.
Totally. And what's interesting as well is that we're always seeing in movies like people directly hacking the hardware, right, the devices. But what you describe actually starts with I would say what a regular attack is, phishing, like email. Someone, got hacked and their credentials were stolen, right? So it starts with something very classical, I would say.
Yeah, and it's also a great example of zero trust, right? Because, you would assume that the people that get remote access to your OT network are trusted. But if somebody steals their credentials, then they're no longer trusted. And yet it's another reason why you need to have a zero trust strategy, even in your OT network.
Nice. And we'll talk about a recommendation in general just after, but you have some other examples. So that one is kind of scary because it actually, human lives are at stake. When something like that happens, it's like cyber terrorism takes a different meaning when it comes to actual, human lives there. You have other examples that might be much closer to people around us.
Yeah, let's look at 3 other examples. So in the first one, this is an attack that was discovered by Microsoft's Security Research Center on voice over IP phones and printers. In this case, there were default credentials, and so the adversary was able to leverage those default credentials to get access to these devices. A voice over IP phone is perfect because it's connected to the internet on one side and to your corporate network on the other side. Once they compromised that phone, the adversary was observed scanning the network, again, just like we saw in the previous example, and looking to elevate their privileges so they could get access to sensitive intellectual property. So another good example of why you need to be monitoring your network and also making sure you don't leave default credentials on your IoT devices. The second example is thousands of attacks that have been launched on smart building access control systems. This wasn't default credentials, it was a vulnerability that never got patched by the manufacturer. And these attacks were being used for DDoS, but you could just see once someone's compromised a building access control system and is using it for DDoS in a botnet, it could just as easily be used for other bad things like locking out the building, locking people in, locking people out, changing the lighting, the heating, the air conditioning, and that's a term that's referred to as siegeware.
The third example, and in that case, actually, was the hardware that was attacked, right? The devices themselves. In the 2 first examples, one was default credentials, right? The typical router in your house that has the admin type of password,
right?
And the second one as well, based on the fact that the device itself was not secure. So the first one was really about phishing and credentials from a human. Here, it's been on the hardware side of things because these devices are accessible and not well protected.
Correct. But even in the first example, phishing was just the first step. It turns out that the security architecture of the safety controllers was such that it made it easy for the adversary to load their malware into those devices. So had they been following more modern security architecture in those devices, it would have been a lot harder for the bad guys to put their backdoor into the safety controller.
Yep. And so you have a third example here.
So the third example is called the VPN filter attack. Again, VPN router is a great place to start an attack on a corporate network because it's facing the internet on one side, corporate network on the other side. In this case, they exploited vulnerabilities in many different, 500,000 different routers to install their malware on the device and gave them complete access to all of the traffic going through that device so they could perform man-in-the-middle attacks, allowed them to sniff the traffic, steal credentials. For some reason, they were looking for Modbus traffic, which is a protocol that is only used in industrial environments. So maybe they were looking to launch similar attacks to what we saw in the Triton case, and then they could execute kill commands on devices inside the network or to destroy the router. So this is a pretty serious attack as well, again, on an IoT device.
Yep. So now you've been scaring us off, it's some place where we need to be careful, right? It's like we are screaming out IoT needs to be secured at various levels. So what is the top to start with before we talk about exactly what Microsoft is doing and offering, to help our customers secure their solutions end to end? What is the top recommendations? What is the approach that needs to be taken to secure these OT applications and infrastructures?
Yeah, so like much of security, it is a defense in depth approach where you need multiple layers of controls. There's basic things you need to do from a hygiene point of view in terms of patching, if you can, implementing multi-factor authentication, if you can, training your employees not to click on malicious links. That's kind of the basics. On the left, you'll see really some basic concepts of zero trust as the foundational strategy, which is verify explicitly. Just because somebody has credentials doesn't mean they're allowed to be there. Implement least privilege access. In a lot of these OT environments, they're flat networks. In many, we're still finding IT networks connected to OT networks directly without even a firewall in between. So that really makes it easy for the adversary to get in there. So assume compromise, which is basically check at every step of the process and implement monitoring so that as a compensating control, so that if somebody's doing something that they shouldn't be doing, you'll notice it right away. And that's the third box there, continuous monitoring. Look for unauthorized or unusual access, and then find a way to automate your response because these attacks happen extremely quickly. So if you're depending on manual responses, you might be too late. Use a SOAR, which is Security Orchestration Automated Response System like Azure Sentinel. And then finally, it doesn't make sense to create a separate SOC for OT. Most organizations have spent 10, 15 years building up their SOC, their operations procedures, their workflows. They already have SIMs, they already have ticketing systems. So it makes a lot more sense to unify these systems in one place. And as you saw from the Triton attack, the attacks often cross the IT-OT boundaries. So you do need that big picture view of what's happening across your entire enterprise.
Okay, Phil, so these are all good recommendations, but what is it that Microsoft is offering? How are we helping our customers secure their OT solutions?
Sure. So we've introduced a product called Azure Defender for IoT. It's an agentless solution, which means it operates at the network layer and it's very easy to deploy. It uses something called passive monitoring, so it has zero production impact. It is deployed in typically less than 1 day, including integration with the SOC. And it has three core functions. It detects unmanaged devices. So for many organizations, they don't know what devices they have connected to the network and how they're communicating. It tells you about what vulnerabilities those devices have and gives recommendations on how to mitigate those vulnerabilities. And it continuously monitors for threats. And then finally, it integrates with Azure Sentinel, but other third-party tools as well, so it can give you a unified view across IT and OT. And that part also incorporates threat intelligence from our threat intelligence team that's specifically focused on tracking IoT and OT vulnerabilities, malware, campaigns, and adversaries. And so that's a way to enrich the information that's being provided to Azure Sentinel. As well, additional contextual information is being sent to Azure Sentinel from Azure Defender for IoT, such as detailed information about the devices that were involved in a given incident.
I see that. Pretty complete now. So if I want to deploy that, what impact is it going to have? What is it that I'm going to need to do to deploy Defender for IoT in my solution?
So let's look at the deployment architecture. So if you look here, you've got your OT network, and you've got devices in the factory or in your facility connected through a network switch. You connect up an appliance, which can be either a virtual or physical appliance, to the span port of the switch. So this is a way to grab a copy of the traffic. It's not inline, so there's no way to interrupt the traffic or to cause any performance impact. And then we use specialized behavioral analytics that understands the protocols and understands the unique behaviors of devices in these environments and does what's called layer 7 deep packet inspection. So you're not looking just at the headers and footers, you're looking at the payload as well. So you could detect, for example, a PLC stop command. And then it sends that information, assets, vulnerabilities, and threats either to an on-premises or cloud connected console. So it can be completely on premises if you prefer. And then it sends alerts to Azure Sentinel or third-party security tools.
Nice. So pretty complete. And what I like in that is the zero performance impact, because you're not replacing something in your existing infrastructure. You're actually just, almost spying on what's going on, right?
Exactly. And, when you talk to the folks in the plant, their number one goal is keep production going, right? They don't want anything that could impact your production. And so that's why this solution is very attractive to them.
Yeah, I like that. It's pretty seamless, right?
Yeah.
And yeah, so if we have to look at what's going on under the hoods then.
Yeah, so these are just some examples. Again, when the folks in the plant or the folks in your security operations team, they want to understand, what are these devices? What types of devices are they? How are they communicating with each other? That's what the blue line shows. How are they arranged in this 4-layer Purdue model that is common in the environment? And then you can drill down into individual devices. You can find out who the manufacturer of the device is, what protocols they're using, IP and MAC addresses, of course, and when they were last on the network. Top right, you can look at the vulnerabilities associated with those devices, and then monitor for threats and alerts, which you'll see if you click it again. That will be the next one. Yeah. So in this case, someone tried to update the firmware. This would be a great example of a living off the land technique, which really Triton was, where someone used a legitimate function, a firmware update or a PLC code update, but they used it in a malicious way. So you definitely want to be alerted when this goes on. Check with the folks in the facility to make sure it was legitimate or not.
And is it fair to say that actually the Cyberattacks addition to Defender, to the traditional Azure tools that we had, is adding that understanding and knowledge about the specificities of the OT world and the IoT devices and protocols, right?
Exactly. I mean, that's why you can't use ordinary tools that were developed for IT security in these environments, because they don't understand the devices, they don't understand the specialized protocols you'll find, and they don't have the right algorithms to detect the behavioral anomalies. And so the benefit of having OT-specific behavioral analytics is it could detect threats faster, with fewer false positives, and with a shorter learning period.
Nice. And so what are the kind of alerts that you would expect on the other hand, right? What is the typically, OT or IoT types of alerts I'm going to see there?
Yeah, so there's a wide range of them. You want to know if an unauthorized device is connected to the network. For example, you have a contractor that came into your facility to fix something. They're not really supposed to be connecting their laptops to your network, but unless you're monitoring, you won't know if someone's doing that. So you want to know if any devices are connected to the internet that shouldn't be. We often find devices still having their call home function enabled, even though you might have a policy that says only very specific devices can connect to the internet. You want to know about unauthorized remote accesses in the case of the Triton, where they came in over RDP to the OT network. And then you'll see some other ones there. Again, some of them might be ordinary functions, but you want to check to make sure they're not malicious, like someone reprogramming a PLC. There's also a number of alerts that'll help the OT team themselves troubleshoot malfunctioning equipment. So if you're getting service request failures or operations that are failing, it could be that one of your devices is misconfigured. And the team, because they're not monitoring their network until now, has not had any easy way to troubleshoot those kinds of issues. And so you're helping not just the security of the facility, but also the operational efficiency and the ability to rapidly troubleshoot issues.
Nice. And that really is about helping OT. But you mentioned also that we need to unify all these toolings, all these reporting, and bring together not just IT and OT, but the overall story there, right? So I think there's also a way of connecting to the business apps, and the business world with the offers that we have, right?
Yeah, I mean, what you're bringing up is really important. There traditionally have been some organizational silos between IT and OT, and for a long time, IT people didn't really understand OT people and vice versa. And what this unified approach does is it brings the teams together. It gives them a common language to describe what's going on, and it gives them a way to collaborate with each other. And of course, Azure Defender for IoT integrates with the rest of the Azure Defender family, which is part of our Microsoft Defender family of XDR, extended detection and response solutions. And as we showed before, also integrates with Azure Sentinel.
Well, that's pretty complete. The decades of experience that Microsoft has in securing IT, the work that the engineers and the experts at Cyberattacks have been doing, put all that together, secure your IT and OT infrastructures. Am I summarizing that pretty much all right?
Sounds great, Olivia. You got it.
Nice. Well, Phil, that was a very insightful, chat. I loved it. I hope I'm going to have you again on the IoT show with more news about how to secure these OT and IoT solutions. We have a link here to learn more about this. On there somewhere about learning more about Azure Defender for IoT and its applications. So aka.ms/IoT show/Azure Defender for IoT. Pretty simple. Phil, merci beaucoup d'être venu aujourd'hui. Everyone, thanks for watching the IoT show. See you soon. Phil.
À bientôt. Merci.